New heading selections are made by rotating the heading knob on the flight mode panel. In response to air traffic control, select heading 240 at the flight mode panel. The flight director provides guidance to the selected heading, and with the autopilot engaged, the aircraft rolls onto the new heading. If the heading bug is off the screen, an arrow indicates the shortest direction to the selected heading. If you wanted to see the heading selection, how would you display heading bug on the compass rose when the selection is off the scale? That's right. As the aircraft rolls onto the selected heading, the flight director commands wings level and maintains the selected heading. Cancel the heading mode and then observe the effects of arming the nav mode. Arming the nav mode automatically engages the heading mode until nav capture criteria are met. The armed nav mode is enunciated by the white VOR symbol in the FMA. For a smooth intercept and capture, an intercept angle of 30 degrees is normally flown. Select heading 300 to intercept. The flight director remains in the heading mode until the VOR capture point. The flight director computer calculates the VOR capture point using VOR deviation signals, DME distance information, course error signals, and true airspeed. When the course deviation bar begins to move, the aircraft enters the nav capture phase. The heading mode drops out and VOR capture is shown by the boxed VOR annunciation. The AFCS provides flight director guidance to the autopilot for aircraft guidance to intercept and track the VOR radio. If an ILS frequency is tuned, the nav mode commands AFCS to intercept and track localizer signals. We will examine localizer and glide slope capture later in this module. As a point of good airmanship, the heading bug is normally selected onto the current course. Select the heading bug to the current course. During station passage, the nav receiver does not receive reliable deviation signals. AFCS maintains the current course until the VHF nav receives reliable signals. As the aircraft overflies the station, the From To indicator changes direction. During station passage, course changes of up to 90 degrees can be made. To check your understanding so far, which summary best describes what happens when the nav push button is pressed, but the aircraft is not within VOR capture criteria? Assume that the autopilot is engaged. That's right. How does AFCS behave during station passage? Please touch the highlighted yes. We have already seen that with a localizer tuned, a captured nav mode provides localizer centerline guidance. Localizer capture is shown by the LOC annunciation in the FMA, and localizer deviation is indicated by the deviation scale on the PFD and ND. Back course approach is used with the front course approach localizer frequency. Back course arms in the same manner as VOR nav, with heading active until course capture. In back course, the localizer deviation bar on the PFD is reversed, and course signals to the flight director are also reversed. VOR approach mode also engages heading until VOR capture. VOR approach mode optimizes radial tracking for distances within 20 miles. The FMS provides roll steering commands to fly along a selected flight plan. LNAV cannot be selected at the FMP unless FMS has first been selected at the EFIS control panel. Flight Director pitch modes are selected at the Flight Mode panel to provide vertical path guidance at the primary flight displays and to the autopilot. Pitch mode selections include pitch hold, the go-around mode, altitude pre-select, altitude hold, glide slope, vertical speed, and IAS. With the autopilot engaged, pitch attitude can be adjusted using touch control steering and at the autopilot control panel. The altitude pre-select function on the flight mode panel is used to provide altitude entry alerting and altitude capture. The altitude selection is made using the altitude knob and the ACL button. Select an initial climb altitude of 5,000 feet and arm the ACL mode. With the ACL mode armed, what do you think the Flight Director pitch bar commands? Choose the best description. Yes. ACL only provides guidance to the selected altitude if the aircraft is within ACL capture range. Go-around, vertical speed, and IAS modes are used to provide guidance to the selected altitude. Vertical speed mode can be used to accelerate the aircraft. Select the vertical speed mode at the flight mode panel and observe the annunciations on the PFD. The vertical speed selection cancels the go-around mode and engages vertical speed mode, shown by the flight mode annunciation. The Air Data Command field shows the commanded vertical speed at the moment of selection. In vertical speed mode, AFCS provides Flight Director guidance to maintain the displayed vertical speed. Engaging vertical speed mode cancels glide slope capture, go-around, altitude hold, IAS, and ACL capture. Note, however, that in this example, ACL on the FMA indicates that ACL is armed. During this initial climb-out, you have cancelled the go-around mode by selecting the vertical speed mode. What do you think your next action would be to reset the pitch datum and accelerate the aircraft with autopilot not engaged? Please touch the highlighted area. That's right. TCS is used to reset the Flight Director pitch command bar for AFCS to command a vertical speed or indicated airspeed. It can be used in conjunction with the autopilot. TCS and autopilot operation will be discussed later in this module. Reset the pitch bar to command a vertical speed of 1,000 feet per minute. Please touch the highlighted area. During TCS operation in vertical speed and IAS mode, the Air Data Command is removed. The pilot flying refers to the appropriate air data instrument for speed or vertical speed. Releasing TCS in vertical speed mode restores the Air Data Command to maintain vertical speed. In this example, at 5 degrees pitch up, the aircraft maintains a climb of 1,000 feet per minute. Assume you're at 180 knots. Select the IAS mode. Selecting IAS mode cancels the vertical speed mode at the flight mode panel. IAS is enunciated in the flight mode enunciator pitch field, and the air data command field displays the indicated airspeed command, in this instance 177 knots. Note that the current indicated airspeed is 177 knots. If the autopilot is engaged, the best way to make minor adjustments to the pitch reference datum is by adjustment of the autopilot pitch wheel. Assume that the autopilot is now engaged. Operate the pitch wheel to increase the aircraft speed to 180 knots. The air data command indicates 180 knots. Note that autopilot pitch wheel operation does not remove the air data command display in IAS or vertical speed modes. In IAS mode, AFCS provides guidance through Flight Director pitch bar commands to maintain the displayed speed. With the autopilot engaged, the aircraft automatically maintains the selected speed. In vertical speed and IAS modes, ACEL has remained armed as the aircraft climbs to the initial departure altitude. Select Altitude Hold now and observe the effects on the current mode. When ALT is selected, all captured pitch modes are cancelled and ALT is enunciated at the flight mode panel and the flight mode enunciator. The aircraft may go beyond the selected altitude depending on pitch attitude when ALT was selected. In this instance, AFCS provides Flight Director guidance to return to and maintain the current altitude. Now cancel the altitude hold mode by selecting vertical speed. Use the autopilot pitch wheel to climb at 1,000 feet per minute and select IAS mode. Please touch the highlighted area. Remember that ACEL is still armed. AFCS maintains the current airspeed until the aircraft comes within pre-selected altitude capture. The ACEL enunciations at the flight mode panel and the PFD indicate that altitude selection is armed. You will recall that the altitude alerting function of the altitude pre-select sounds the C chord at altitude entry 1,000 feet above or below. As the aircraft approaches selected altitude, pilot attention is drawn to the ACEL capture phase by the boxed ACEL enunciation. After 5 seconds, this enunciation changes to ACEL capture, indicating that AFCS commands a fixed rate of closure to the selected altitude. ACEL capture is cancelled when the aircraft reaches the selected altitude and the ALT mode engages automatically. AFCS reverts to the basic pitch hold mode if the autopilot pitch wheel is rotated during the ACEL capture phase or in the altitude hold mode. The ACEL mode or the ALT mode is cancelled and the flight mode panel and FMA pitch indicators are blank. Based on what you have learned so far, what do you think happens when a new altitude is selected during the ACEL capture phase? That's right. Select a new altitude and observe the enunciation on the PFD. Selecting a new altitude during the ACEL capture phase rearms ACEL. AFCS maintains pitch hold until a new pitch mode is selected at the flight mode panel. On approach, with an ILS tuned, arming the glide slope mode arms AFCS to track the localizer beam and follow the glide slope signals. Arm the glide slope mode at the flight mode panel. The glide slope mode arms the localizer mode if it is not already armed, and simultaneously arms the glide slope mode. Glide slope can be armed in any pitch mode except go-around. Glide slope capture is inhibited until after localizer capture, shown by the boxed and then green localizer flight mode annunciation. Glide slope capture can be made from above or below the glide slope beam. Capture is indicated by first the white box and then the green GS annunciation. To check your understanding, what does the flight mode panel setup indicate? Yes. What selections would you make for tracking a VOR in vertical speed of 1500 feet per minute to an altitude hold at 6,000 feet? That's right. Touch control steering buttons are installed on the outboard horn of each control wheel to allow pilots to change the pitch mode reference datum. Operation of TCS cancels the go-around mode and sets a new pitch reference command in basic pitch, vertical speed, IAS and altitude hold modes. Operate TCS with no autopilot engaged and observe the effects on the PFD. During TCS operation, the flight director pitch command bars are zeroed to the aircraft symbol. Movement of the control wheel maneuvers the aircraft. Note that in vertical speed and IAS hold modes, the air data command display is removed until TCS is released. When the TCS button is released, the flight director pitch command bar indicates the pitch attitude required to maintain the new vertical speed, IAS or altitude. The rolled command bar provides guidance to return to the previously active roll mode. In this example, the flight director maintains the new pitch attitude and commands return to the previously selected heading. To recap on what you have seen so far, decide which of the following statements about touch control steering is not true. Please touch the highlighter. That's right. Operation of touch control steering with the autopilot engaged is similar to operation without the autopilot engaged. TCS can be used to reset the pitch bar to command a new vertical speed, IAS or altitude. Operate TCS and observe the PFD and flight mode panel. Operation of TCS with the autopilot engaged overrides the autopilot commands to the servos whilst the button is pressed. The AP light on the flight mode panel extinguishes to indicate the declutched state. The flight director pitch command bars are zeroed to the aircraft symbol. Steering movement at the control wheel is directly realized at the flight control surfaces. On releasing TCS, the autopilot engage light illuminates, indicating that the autopilot servos operate the flight control surfaces. The autopilot maintains the pitch datum commanded by the flight director at the moment of TCS release in vertical speed, IAS, altitude hold, and basic pitch modes. With the autopilot engaged, the aircraft resumes tracking the previously selected heading, VOR, localizer, back course, LNAV, VOR approach, or glide slope. If no roll mode is active during TCS operation, the autopilot maintains the new heading. Bank angles more than 6 degrees on TCS release are maintained. Bank angles of 6 degrees and less on TCS release causes the autopilot to roll out and maintain wings level. Bank angle is limited to 40 degrees during TCS operation. Note that with the autopilot engaged, touch control steering can only be used if the autopilot turn control knob is in the detent position. You will recall from earlier in this module that the autopilot and flight augmentation system provide pitch and roll commands for flight path control and yaw damping and turn coordination for aircraft stability. In addition, the autopilot outputs elevator trim commands. The autopilot and yaw damper are engaged by pressing the autopilot engage button on the flight mode panel. Engage the autopilot. Note that the autopilot engaged light illuminates on the flight mode panel, and the yaw damper engage light illuminates on the autopilot control panel. Selecting the left or right autopilot command determines which flight director provides steering commands to the autopilot. What would you do to exchange the right flight director control for the left flight director? Yes. The autopilot can be disengaged from either autopilot cutout button on the control wheels. Disengage the autopilot and select the right flight director. Then reselect the autopilot. Disengaging the autopilot manually sounds a single cavalry charge. The autopilot annunciation extinguishes on the flight mode panel, and the yaw damper annunciation extinguishes. You will recall that go-around selection from the power levers also disengages the autopilot. Now select the first officer's autopilot command and re-engage the autopilot. The autopilot commands heading hold and pitch hold if it is engaged with no flight director mode selected. The autopilot commands wings level and heading hold when the bank angle is less than 6 degrees. The autopilot servos can be controlled directly from the autopilot control panel by operation of the pitch wheel and turn knob. The autopilot pitch and roll axes are automatically coupled to the flight director mode selections made at the flight mode panel. Engage heading select and altitude hold. The autopilot turn knob is moved out of the detent to produce an autopilot roll command. Move the turn knob to produce a bank angle of 10 degrees. When the turn knob is moved out of the detent position, the current roll mode is cancelled. Note that the roll mode annunciation and the flight director roll command bar are both removed from the PFD. Increase the bank angle to 30 degrees. The position of the autopilot turn knob produces a proportionate bank angle command to the autopilot roll servos. To reselect a flight director roll mode, the autopilot turn knob should be in the center detent position. Roll the aircraft to wings level and engage the heading select mode. Moving the turn knob to the center position rolls the aircraft to wings level and heading hold. Note that the flight director roll bar does not reappear. and no Flight Director roll mode is active. Engage the Heading Select roll. Engaging a new lateral mode causes the Flight Director command bar to reappear and the mode enunciation in the FMA. The autopilot turns the aircraft onto the heading set at the heading bug. Autopilot pitch control can be pilot selected from the pitch control wheel. Select a pitch up attitude of 3 degrees. Moving the pitch wheel in altitude hold mode or during the ACL capture phase cancels the pitch mode. The autopilot maintains pitch hold until a new pitch mode is selected. Now select ACL and vertical speed. Adjust vertical speed to 1000 feet per minute climb. You will recall that the vertical speed command from the Flight Director pitch bar can be adjusted either through touch control steering or autopilot pitch wheel movement. Use the autopilot pitch wheel to adjust the vertical speed to 1000 feet per minute climb. The pitch control wheel can be used to reset the pitch datum in vertical speed mode and IAS mode. Pitch wheel signals and turn knob signals are inhibited after glide slope capture. The autopilot cannot be engaged if the autopilot turn knob is out of the center detent position, or if autopilot disengagement criteria apply. The autopilot will only engage if power is available, there are no disconnect conditions, one autopilot channel is operational, there is no stall warning, and the flight control lock is off. The yaw damper automatically engages when the autopilot is engaged, except when the autopilot is engaged on the ground for test purposes. The yaw damper can be engaged manually in non-autopilot coupled flights by pressing the yaw damper push button. Engage the yaw damper. The yaw damper provides yaw damping and turn coordination. The yaw damper is manually disengaged by pressing the autopilot cutout button, and automatically disconnected when go-around is selected or the landing gear is selected down. In this sample flight, the aircraft is flown from the right-hand seat. Not all aspects of the flight will be discussed. Examples will be given to demonstrate AFCS operation within a flight context. Normal setup for mode selection while the aircraft is on the ground is to engage go-around and heading select and arm ACL. Please touch the highlighted area. Please touch the highlighted area. That's right. Selecting a go-around gives a Flight Director pitch target of 8 degrees pitch up and wings level. After takeoff and initial climb, flaps are selected up at flap up speed or more, and the pilot flying calls for the IAS mode for speed hold. Select IAS now at 1200 feet radio altitude. IAS cancels the go-around mode. Current airspeed is 139 knots. Use touch control steering to reset the pitch datum to command an IAS of 160 knots. Bringing the nose down has accelerated the aircraft to a speed hold at 160 knots. Normal climb is executed with a vertical speed of 1000 feet per minute and then a speed of 180 knots. Engage the autopilot and vertical speed mode and use the autopilot pitch wheel to command a vertical speed of 1000 feet per minute. Engage the autopilot. With the autopilot engaged, the flight director commands are coupled to the autopilot servos. You will recall that the first officer's flight director is selected for autopilot control. Continue by selecting vertical speed at 1,000 feet per minute. At 4 degrees pitch up, the aircraft will climb with a vertical speed of 1,000 feet per minute and accelerate towards optimum climb speed. You should be aware that power management is a pilot function. As the indicated airspeed approaches 180 knots, engage the speed hold mode to maintain the normal en route speed. Assume you are now at 180 knots. As in vertical speed, power management is a pilot function. Fine-tune the speed to 180 knots. During your climb, ATC directs you to maintain heading and level due to traffic. Press the appropriate control. Alt-hold cancels the vertical speed but not the armed ACL mode. Note that AFCS captures the altitude at the moment Alt is pressed. ATC now clears you to continue climb. As your speed difference is not great, use IAS and the AP pitch wheel to resume climb. Use the pitch wheel as the aircraft arrives at 1,000 feet below the selected altitude. The altitude alerting system sounds the C chord. As ACL captures, AFCS loses the IAS hold mode. ACL captured represents a fixed rate of closure to the altitude. Boxed ACL draws pilot attention to the mode change. The boxed ACL annunciation disappears after 5 seconds and the ACL mode is active until the altitude mode captures. Your navaid is correctly tuned. Set an outbound course on the 240 radial and ARM nav mode. Set a course of 240. ARM nav. The heading mode remains active until AFCS captures the course. Set a heading of 210 to provide a 30-degree intercept. The autopilot rolls the aircraft to the selected heading. Bank angle depends on displacement between the heading bug and the aircraft nose. AFCS moves from heading to nav and rolls the aircraft onto the selected heading. The capture phase is enunciated by the boxed VOR mode, and the aircraft tracks the selected radial. As a point of good airmanship, you should put the heading bug on the selected course. Select heading 240. For the approach phase of this sample flight, you are positioned for the ILS approach. You will recall that on airfields where there is no ILS, the VOR approach mode optimizes VOR signals within 20 miles. To commence descent, select an approach altitude of 2,400 and ARM ACL mode. Then initiate a vertical speed descent at 1,500 feet per minute. Commence descent. When the indicated airspeed has increased to 215 knots, you should select IAS and reduce power to about 35% torque. Select IAS. That's right. For a suitable intercept of the ILS on runway 33, use the heading mode to roll the aircraft to heading 060. Select heading 060. With heading select, the aircraft rolls to the new heading. Once the ILS is tuned, the glide slope and localizer scales appear on EFIS. Select heading 000 for a smooth intercept and arm the glide slope and localizer mode. You will recall that with an ILS tuned, pressing nav arms the localizer mode, and pressing glide slope arms the glide slope and localizer mode. Arm glide slope and localizer for the ILS approach. Please touch the highlighter. Note the current FMA indicates that ACEL and glide slope pitch modes are armed. As ACEL captures, the IIS mode is cancelled. Boxed ACEL changes to ACEL and then to Alt Hold. Glide slope remains armed. The localizer capture phase is announced by the boxed loc annunciation, which reverts to the localizer capture mode. AFCS steers the aircraft onto the extended centerline. You will recall that glide slope capture is inhibited until after localizer capture. At glide slope capture, the Alt mode is cancelled. Pitch wheel inputs from the autopilot panel are ignored. Due to traffic on the runway, you select a go-around. Activate the go-around, and the go-around gives an 8-degree pitch-up target for safe climb-out, disengages the autopilot, and cancels all other modes. The flight director roll bar maintains wings level. You are now back on finals with the autopilot engaged. Disengage the autopilot. With the autopilot disengaged, the aircraft is manually flown. At 200 feet radio altitude, the runway symbol appears. And at touchdown, you are likely to lose the glide slope signal. When engaged, the autopilot provides automatic elevator trim signals to aerodynamically balance the aircraft. Elevator trim removes the need for continuous torque from the elevator servos. If the autopilot goes out of trim for more than 12 seconds, a Level 2 alert is presented, and a trim light annunciates on the Automatic Flight Control System status panel. The trim annunciators up and down indicate the direction that requires trim. The autopilot and yaw damper functions of the Automatic Flight Control System incorporate channel monitors that detect servo failures in the pitch, roll and yaw axes. Failures are localized to the affected channel. A single channel failure occurs when a fault is detected and localized to a specific channel in one or more than one axis. In this example, a single channel failure is detected in the autopilot roll axis. The autopilot deselects the failed channel and reverts to single channel operation in the affected axis. The AFCS status panel indicates the affected channel. Note that a single channel failure does not disengage the autopilot, alter the current flight path, or lead to AP out of trim conditions. The affected channel is, however, no longer fail passive. The autopilot also reverts to single-channel operation if it detects a data fault from either AHRS-1 or AHRS-2. Which of the following conditions do you think does not result in autopilot single-channel reversion? That's right. A dual-channel autopilot failure occurs when a failure is detected that cannot be localized to a specific channel, or when reversion to single-channel operation is unsuccessful. A dual-channel failure in the pitch and roll axes automatically disengages the autopilot. A dual-channel failure is presented by flashing annunciators in the affected axis and a continuous cavalry charge. Pressing the AP cutout button cancels the cavalry charge. A dual-channel yaw damper failure presents flashing yaw damper lights on the AFCS status panel and a level 1 alert. The autopilot remains engaged following a yaw damper dual-channel failure. The autopilot is manually disengaged from the AP cutout button on the control wheels and the go-around buttons on the power levers. Automatic disengagement occurs when the stick shaker is activated as a stall warning, if the flight control lock is on, if a data fault occurs in both AHRSs, if power is removed from both channels, or if reversion to single-channel operation fails. An automatic disengagement results in a continuous cavalry charge. Cancel the cavalry charge. The yaw damper is automatically disengaged whenever the autopilot is automatically disengaged. If only the yaw damper was engaged, automatic disengagement is announced by a level 1 alert. If no autopilot is engaged, the yaw damper is automatically disengaged when the landing gear is selected down. Which conditions lead to an automatic disengagement of the autopilot? Please touch the highlight. Yes. If the autopilot fails to automatically disengage, a continuous cavalry charge advises the flight crew of the disengagement failure. In both instances, the autopilot can be disengaged at either control wheel and the affected channels selected off at the AFCS status panel. The automatic flight control system on the Fokker 50 provides flight director guidance and autopilot control in pitch, roll and yaw. The AFCS comprises 2 flight directors, a dual-channel autopilot, dual-channel flight augmentation computer and single-channel output to autopilot trim. AFCS controls and indicators are located on the flight mode panel, the AP control panel, and the AFCS status panel. The flight mode panel incorporates controls for flight director pitch and roll mode selections, flight director selection and autopilot engagement, altitude preselection, and heading and course selection. Either the left or right flight director can be coupled to the autopilot for aircraft guidance. Flight director selection is inhibited when the autopilot is engaged. With the autopilot engaged, aircraft pitch and roll can be controlled from the pitch wheel and the turn knob on the autopilot control panel. The AFCS status panel indicates the status of both autopilot channels in roll, pitch and yaw, and indicates when the autopilot has been out of trim for more than 12 seconds. The autopilot is manually disengaged by pressing the AP cutout buttons on either control wheel, and when the go-around buttons are pressed on the power levers. In autopilot coupled and non-coupled operation, touch control steering can be used to manually maneuver the aircraft and reset the pitch datum. The yaw damper can be used independently of the autopilot in non-coupled flight by selecting the yaw damper on at the autopilot control panel. The yaw damper is manually disengaged by pressing the AP cutout button on the control wheel and selecting Go Around. Automatic disengagement takes place if autopilot disengage criteria are met, or if the landing gear is selected down when the autopilot is not engaged. The autopilot is automatically disengaged if there is a data fault from both AHRS, the flight control lock is on, or the stick shaker is activated. The autopilot automatically disengages if a failure is detected in the pitch or roll channels that cannot be localized to a specific channel. Yaw channel failures do not lead to autopilot disengagement.